Hey guys, in this video we're going to talk about descriptive and correlational research together. Okay, so let's start with descriptive methods. So we talked about descriptive statistics already. So descriptive statistics are describing your data, mean, median, mode, variability, but that is different from descriptive research. Okay, it's kind of the same concept, but it's different. So descriptive research, you're just describing the characteristics of some phenomena. Okay? You're not inferring anything from groups. You don't even have groups probably. No treatment or control groups, right? You're just describing what's happening. Two examples that we're going to talk about today in this video specifically are survey research. If you've ever been given a survey or had a cashier say, oh, fill out the survey at the bottom of your receipt, you've participated in descriptive research. Okay? The other one we're going to talk about is correlational studies. This is looking at the relationships between variables or relationships between a couple of items. Okay? So two things we'll talk about specifically today. So survey research. Okay, looking at frequencies and relationships between a variety of variables, usually psychological, sociological, could be criminal justice related. Things that are really common on surveys are things like attitudes, beliefs. A couple of really specific examples are going to be voting preferences, drug use, things like that. You can get at some pretty sensitive information in survey research. That's one of the good things about survey research. It also is good if you have different methods for survey research. You could have a web survey, you could have a phone survey, you could have a face-to-face interview. There's lots of different ways to do survey research, especially nowadays. Okay? So general plan, what are we going to do with survey research? Okay, 4 basic steps. First step is talk about the objectives. What do you want to know from your survey research? You have to be really, really clear about this. Okay, identify a sample. We talked about that in our sampling module. Okay, define a method. There's lots of things that go into this. Okay, several questions you want to ask yourself. There we go. How are you going to structure the questions? Okay, are you going to have open-ended questions? Are you going to have closed-ended questions? That's something really important to decide. Are you going to have a mixture? You can have a mixture of open and closed-ended questions. How will the sample be defined? Okay, how will the data be collected? This is getting at what I mentioned earlier, right? Are you going to do paper, pencil, online, face-to-face? How are you going to collect data? You're going to use all those methods? You're going to smush them all together? And what types of questions will be asked? This gets really tricky. Wording a question for a survey, I took a whole class on that. So this is really, really important. Okay? And then last, coding and scoring. So coding and scoring, how are you going to code your variables? How are you going to score your surveys? Very, very important. Last step. Okay? For this class, that's where we'll stop. In the next class in stats, you know that we go on and analyze the data that's been coded and scored. But for here, that's where we'll stop. Okay? So let's talk about advantages and disadvantages. Survey research is great. Super great. Okay? You have good generalization because you can get a really good sample, a big sample, right? The bigger the sample, the easier it is to generalize out to a population. Really efficient data collection. There's lots of software out there now that will automatically just put your data into Excel or SPSS or some kind of analytics software. You don't have to type anything in, just automatically imports it. It's great. Okay? It can also yield really accurate results. Going back to that sample. Bigger the sample, more accurate the results. Okay? Some disadvantages. You have some bias that gets present, particularly if you have face-to-face interviews. Okay? You have interviewer bias. This happens whenever an interviewer either leads the person to a certain answer during an interview or words questions differently for different people. You also have interviewee bias. This is the person being interviewed. Sometimes what will happen, people being interviewed, they want to sound good. So they may not give 100% honest or accurate results or answers because of this bias. The disadvantage, biggest disadvantage is non-response. This has several different terms that go with this. Sometimes it's called a mortality rate, attrition rate, non-response rate. Those all mean the same thing. This is when people either drop out or just click delete on the email that you sent for them to read. Okay? That's a non-response rate. That's what that's called. Big problem. To get around the non-response rate, you have to oversample, usually by 20 to 50%, depending on what you're asking and how long your survey is. Huge problem. So with correlational studies, we're moving away from just asking people questions. Okay? Because when you ask people questions, you're just going to describe what's happening, talk about percentages, frequencies. With correlational studies, we're actually going to look at the relationship between two variables. Okay? So this is a linear relationship, there it is, between two variables. Okay? Now it's important to remember, this does not imply a cause and effect relationship. Just because two things are related to one another does not mean one causes the other. Okay? The only way to establish cause and effect is with experiments, which we'll talk about in the next module. Okay? It does imply that the variables have something in common. Okay, so no cause and effect, but it does imply something is in common with the two variables. Okay? So let's talk about the basics. So there's a linear relationship between two things. Okay, so that means on a line. 0 is going to be here in the middle. So what you'll do in the stats class, when we talk about correlations, you'll have a data set, you'll crunch, 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 and you'll spit out a number. Okay? So correlations, again, with abbreviations. Remember, significance level is abbreviated as a P. Correlations are abbreviated as a lowercase r. How I remember that? R for relationship. You're looking at the relationship between two things. Okay? So what we do is pop that into our handy-dandy stats software, and out pops the number. And that number is going to be between -1 and +1. If it's outside of -1 to +1, something has gone horribly wrong with your data set, and you need to go back and re-examine what happened. Okay, so anywhere between here is what will pop out. Okay? So this tells us a couple of things. Okay? The strength of the relationship. The stronger a relationship is, the closer to 1 it will be on either end of the number line, -1 or +1. Okay? It also tells us the direction, how the two numbers vary, or how the two variables change with each other. Okay? So you have strength. Okay, -1 is good, +1 is just as good. There's nothing wrong with being on the negative side of the number line. Okay? So what does this mean? Positive correlations. Anything over here on the positive side of the number line, that's all that means. Doesn't mean anything good, it just means it's on that half of the number line. Means that the variables change in the same direction. So as variable 1 goes up, variable 2 goes up. Okay? As variable 1 goes down, variable 2 goes down. Okay? So it's a positive correlation. So example, in the summertime, the temperature goes up. Okay? What else goes up in the summertime? Ice cream sales. There is a positive correlation between the temperature outside and the amount of ice cream sold. Okay? Notice those two things are both numbers, right? Temperature is a number, amount of ice cream sold. Okay? It could be in ounces, it could be in cartons, something along those lines, but it's still a number. Okay? Those are positively related. Okay? One goes up, the other goes up. Same thing in the wintertime. Wintertime, temperature goes down. Ice cream sales go down. It's a positive correlation. Just because they're going down, they both go down. Okay? Now, on the other half of the number line, let's talk negatives. Okay? The negative half of the number line indicates a negative correlation. Okay, what does this mean? As 1 goes up, variable 2 goes down. As variable 1 goes down, variable 2 goes up. So they move in opposite directions. Okay? So negative correlations don't have to be bad. For example, Amount of orange juice consumed. As it goes up, the risk of cancer goes down. That is a negative correlation. Is it a bad thing? No, it is not a bad thing. But it is a negative correlation because they move in opposite directions. Okay? So the direction of the relationship is indicated by the value of the number. The value of the number also indicates strength. Closer to 1 is better. Okay? So how do you categorize these? This is the eyeball method that I'm a huge fan of. Okay? We've got different categories and then different labels for them. So anything between 0.0 and 0.2 is very weak. Okay? You notice there's positive and negative here. It does not matter which side of the number line it's on. That is an absolute value. Okay? Anything between 0.8 and 0.1, or 1.0, sorry, is considered very strong. Okay? So when I ask you which of these correlations is the strongest, you'll want to look at these and select the one that is closest to 1.0. Okay? That's all I want you to know for correlations. We'll talk way more about correlations in the stats class. Okay? If you have any questions, let me know.